Welcome to the first video about parallel lines being cut by a transversal. But what are parallel lines? Parallel lines are the ones that never intersect. Now, as a quick reminder, back in algebra, we talked about parallel lines. They have the same slope. So they're just two lines that are going in the same direction, either positive or negative, but they're two lines that will never intersect like that. I could make them going in the opposite direction. They're awfully close together. So those two are close together, but they are parallel. I understand if you look like they're not lined up, it doesn't matter. They don't have to be the same length in any way. They just will never intersect, even though they're so close together. These are two examples of parallel lines. All right, so the transversal part. Transversal is pretty simple, straightforward. It's a line, a ray, or a segment that intersects two or more lines. So together in our geometry classes, it creates a diagram that looks like this. Our parallel lines are the ones going horizontal here. They will not always be horizontal. The transversal is the diagonal looking one. It's the one that's crossing our two parallel lines. Sometimes you will see the lines named, maybe with like a line L and a line M. But we end up with 8 different angles here. First intersection has the angles 1, 2, 3, and 4. Second one has 5, 6, 7, and 8. So there are some specific types of angles that are created when two parallel lines are cut by a transversal, and one of them is being exterior angles. So let's go ahead and define exterior angles. So exterior angles are the angles on the outside of the parallel line. So these are our two parallel lines. You can kind of see that it creates this outside, inside, outside. Kind of think of it like a sandwich. So outside, inside, outside. So in this example, angle 1, angle 2, angle 8, and angle 7. These are going to be our exterior angles. And we'll talk about the inside angles or interior angles in another video, but this video is just going to focus on these exterior angles and their relationship. You first have to be able to define them or find the exterior angles and understand where they are. So you have these two parallel lines cut by a transversal. The transversal part doesn't even really matter right now. The exterior is coming from the fact that it's outside of those two parallel lines. So angle 1, 2, 8, and 7 are the exterior angles. Now we're going to specifically be looking at alternate exterior angles. So there's two parts here that I want to make sure that we understand. First of all, alternate means that they're on opposite sides of the transversals. So opposite sides of the transversal, still dealing with the exterior though, so still honing in on the angles 1 and 2 and 8 and 7. The alternate part is where the transversal comes in. So this is now where we're worried about looking at that transversal that's going through the two parallel lines. So the opposite ones would be the ones that are on opposite sides, or the alternate ones would be the ones on the opposite sides of the transversal. So angle 1 is on the opposite side of angle 7. So angle 1 and angle 7. And then angle 2 and angle 8. Angle 2 and angle 8. Those are your pairs. Those are alternate exterior angles. They are on the outside of the parallel lines and on opposite sides of the transversal. And this is important because they have a special relationship. Kind of look at this here, okay? This transversal is cutting this line. We have a skinny angle, and then we have this skinny angle. Sorry, we have an acute angle, and then we have an obtuse angle. Down here, we also have an obtuse angle and an acute angle. Well, these lines are parallel. This is that same transversal. What do you think is going to be the relationship between 1 and 7, those two acute angles, and 2 and 8, the two obtuse angles? Well, if you guess that alternate exterior angles are congruent, you would be correct. So now, not only have we identified what the alternate exterior angle pairs are, but we can also say that angle 1, so the measure of angle 1, is congruent to the measure of angle 7. So those things would actually have the exact same value. So angle 2 is congruent to angle 8. Their measures are going to be equal. The angles are congruent. That's very helpful when trying to find missing angle values or variables, if the case may be. So this first example of how we're using that relationship where they're congruent, we're going to find the value of x. Well, we're trying to figure out the angle measure over here because x is labeled with a degree, and I know that it's on the outside of the parallel lines up here, and the only other thing that's labeled for me is the 137 down here, and that's also on the outside. And if you compare their position to the transversal, they are on opposite sides of the transversal. So they are alternate exterior angles, which means that they are congruent. So I can say that x equals 137 degrees by alternate exterior angles. Okay, so no work. Just from their placement, I know the value of x. This next problem has a couple things flipped around. We can see that the parallel lines are now they're sloped upwards, but they're still never going to intersect. And the transversal is actually our horizontal line. So this is just to show you that it does not always have to be parallel lines perfectly horizontal or even perfectly vertical. The parallel lines can be the sloped lines as well. Either way, the 2x plus 4 degree is on the outside of the parallel lines, the 80 is on the outside of the parallel lines, and they are on opposite sides of this transversal. The 2x plus 4 is on the top, the 80 degrees is on the bottom. So by alternate exterior angles, I can say that 2x plus 4 equals 80. And so the equal part is coming from the fact that they are alternate exterior angles. That's the theorem. That's their relationship. They are congruent, which means they are equal measure, so I can solve this problem to find the value of x. So x equals 38. In this final example, still using the alternate exterior angle relationship. The parallel lines are back to being horizontal, slanted transversal. 10x plus 11 degrees is on the top side on the exterior. 8x plus 35 degrees is on the bottom side exterior in relation to these parallel lines. Outside, outside. In relation to the transversal, they are on opposite sides. The 10x plus 11 is on the right-hand side. The 8x plus 35 is on the left-hand side of the transversal. They're alternate exterior, which means that they are congruent, which means I can set their angle measures equal to each other and solve for x. So after solving, x equals 12 in this problem, again using alternate exterior angles. Thanks for watching.